Let's start with reading this problem and identifying our givens and the questions. A light string with a mass per unit length. Mass per unit length means it's the linear mass density mu, has its ends tied to two walls separated by a distance equal to the 3/4 of the length. I'm going to denote the length as a capital L, and the walls are separated by 3/4 of the length of the string. An object of mass m, here's my object, mass m, suspended from the center of the string. Well, it says center of the string. That means this part is L over 2. This other part is also L over 2. A, find an expression for the transverse wave speed. So it's asking us to find V expression in the string as a function of mass. So V function of mass, that's what they're looking for. And part B says, what should be the mass? So here is the mass, that is a question, of the object suspended from the string if the wave speed, now we have in the second part V given to us. Okay, so now let's make sure that we organize these givens and unknowns and knowns in a list, so we won't look in the words often. So we're given the mu equals 8.00 grams per meter. Let's recall this is grams. Maybe we need later to convert it to kilograms. It's not maybe, it's for sure we will need it. Let's just do it right now. So it's 8 times 10 to the negative 3 kilograms per meter. Okay, so what else is given to us? For the part B, we know that V is 60 meters per second. So let's remember that this is for part B, so we're not allowed to use that in part A. So then we're looking for, in part A, we're looking for an expression of velocity as a function of mass. On the second part of the problem, we're looking for the mass for a given speed of the wave. Now, to solve this problem, the first part, I need to recall, what do I know? I'm asking myself, what do I know about the speed of wave? So I know that we found that the speed of wave equals square root of force of tension divided by the linear mass density. So we have no problem with the linear mass density, but we need to find force of tension. Now let's see, what do we know about the speed of the wave? We know that the speed of the wave equals square root of force over the mu, force of tension. So now the question is, how can we find the force of tension? So we know that force of tension could be found by probably by a free body diagram, because our object is in equilibrium. So for that, I'm going to draw forces that act at this point right here. So at this point, we have one force that is going downwards. That's the weight of the object. And then we have a tension of the string to the right and tension to the string to the on the left side. So let's just draw in a different, cleaner place so we can have our coordinate system also in action. So here is the X going to the right, Y going to the top. This is our point of interest. Now we have mg going downwards as a free body diagram. I have a tension to the right and then tension to this, to the left, and then obviously this angle should be theta, and they are equal angles because of, if we go back to the picture, the diagram we had, you can see that because of it's a right triangle and one sides are equal to each other, so these angles should actually be equal to each other. So maybe I should, it would be better if I draw it like with the black, theta and theta. Now the next thing, all I need to do, probably find the cosine theta or the theta. How do I find the theta? Now I'm gonna go back to the diagram and look at one of these right triangles right here. So I can draw in here the right triangle to find the theta because we would need it. So if you look, this was half of the length of the string. The other side though was half of the distance between the walls. So that would be half of the distance between the walls, which was 3/4L. Okay, so we're looking for this angle theta. From here, I can say cosine theta equals adjacent over hypotenuse, that is a 3/8L divided by 1/2 L, that gives us a 3/4. So we can evaluate the theta, and that will be equal 41.4 degrees. Now that we have solved the problem with the theta, let's go ahead and find, go back to our free body diagram and write the equilibrium conditions. So I can resolve the tension into components, x and y components. You can see that the x components of the tension would actually be equal to each other. So this is t cosine theta, this is t cosine theta, so they will cancel each other. However, the y components would equal t sine theta would add up. So we will end up having 2 times t sine theta equals mg. So I think we decided that we're not going to use the tension as a t, so but it's too late already. So my tension would be, I'm going to have this tension is the same as a force of tension. So let's write force of tension sine theta equals mg, and then from here I can find force of tension equals mg over 2 sine theta. Okay, so now I can take this one and plug it in here. Now let's write V equals square root of mg over mu times 2 sine theta. Okay, well, we need to plug in the numbers. So here we have 9.8 meters per second square divided by our mu was, actually we have, our mu was, what was it, 8 times 10 to the negative 3 kilograms per meter times 2 times sine of, we got 41.1 degrees. Okay, so I need to prolong this guy here. And then of course I separated the square root of m because we don't know anything about it. So this expression with numbers I'm going to plug in my calculator, and that will give me 30.4 meters per second over square root of kilogram times square root of m. So this would be the function of v in terms of m. Okay, so we're done with the first part of our equation problem. Now let's do the second part of the problem. The second part of the problem is we have v equals 60 meters per second. So I can use this expression of that I found v equals 3.4. Actually, it's not 3.4, it's a 30.4 meters per second square root of kilograms times square root of m. We want to find the mass here, so I could say the mass equals, okay, so v over 30.4 meters per second over square root of kilograms and then squared. Okay, let's plug in the value for v. So what was our v? Let's go up and see what was our v given. It's a 60 meters per second. Let's plug that in. Oops. So that's a 60 meters per second divided by 30.4 meters per second over square root of kilogram. See, these two will cancel out, and there is the square root of kilogram will come to the top, and when you square it, the result will be kilograms. And plug this into a calculator. Most probably you will get 3.89 kilograms. So, problem solved. Thank you for watching.